As I said in class, the log laws are very closely related to the index laws. So if you can remember your index laws, then the log laws are going to be much simpler to remember. So consider this. If I have two indices, a to the power of m and a to the power of n, and I'm going to call them x and y. So my first thing is to say, well, what does that mean as a log? Well, what that means is that log, so then it's base, answer, equals the power. Okay, so log base a of x is equal to m, and similarly log, and then it's base, answer, power. So log base a of y is equal to n. Okay, now come back to the indices. What is a to the power of m times a to the power of n? Well, we know in that case that we need to add the indices. It's just m plus n. Okay, but go back to your a to the m is equal to x. This is the same as xy. Okay, so xy is equal to a to the power of m plus n. What happens if we write this as a log? Well, from here we get that log of the base, so a, the answer, xy, is equal to the power, m plus n. Okay, so nothing new there. We've just written that as a log. But up here we said, but m is equal to log a of x, and n is equal to log a of y. So I can rewrite this as log a to the x plus log a to the y. So that's our log law. If log base a of xy of some product, then what we can do is we can separate them up into log base a of x and log base a of y. And that works both ways. So you can go either way. If it is a product, you can separate the factors. If it's in factors, you can combine them for the product. And that becomes very handy when we have something like this first example. So see where we have log base 10 of 20. 10 to what power equals 20? That's not something that we know. Log 10 of 5. 10 to what power equals 5? Again, not one that we easily know or work out. But what we can do is look at that and say, well, what is 20 times 5? 20 times 5 is 100. So this is the same as log base 10 of 100. Now it only works because they've both got the same base. It doesn't work if they're different bases. But because they're the same, we can combine them. Well, 10 to what power is equal to 100? That one should be pretty easy. That's 10 to the power of 2. Okay, so have a look at your second rule. What do you think is going to happen if we have a quotient? If instead of x times y, we have x divided by y? Well, think about your indices. What do you do to your powers if we are dividing indices with the same base? We subtract the powers, don't we? So this kind of works the same way. It's going to be log base a of x minus log base a of y. So again, your example here, log base 2 of 20 minus log base 2 of 5. Well, I don't know what power I can raise 2 to get the answer of 20, but what I do know is that because I am subtracting them and they both have the same base, that this is the same as, whoops, in the right colour, log base 2 of 20 over 5. Well, 20 over 5 is 4. So this is the same as log base 2 of 4. 2 to what power equals 4? 2. Okay. The next one's a little bit different. Log base a of x to the power of n. This is equal to n times log base a of x. So you can actually bring your index out the front and then just multiply that. So what does this look like when we look at an example? Well, we have log base 2 of 10 to the power of 7. So this is equal to, you bring the index out the front, 7, and then we have log base 2 of 2. Okay, well, 2 to what power is equal to 2? That's 1. So this is 7 times 1. So this is just 7. What I would like you to do is think about that last law, this one just here, and see if you can figure out why. If you can come into class and explain to me why that rule is. I don't know, we'll go with the chocolate bar. What do you reckon? Okay, so how can I use this? Well, if you are given some values for some logs, so in an exam, this would be an exam style question. Given that log base 10 of 2 is equal to 0.3010 and log base 10 of 3 is equal to 0.4771, find log base 10 of 6. So what you need to do is look at what we're trying to find the log of. Now these all have the base 10, so we can use our log laws. 6, how do I get 6 from 2 and 3? Hopefully we can all say, hey, that means we're multiplying, yeah? 2 times 3. But our log laws tell us that that is the same as log base 10 of 2 plus log base 10 of 3. Because 6 equals 2 times 3. And just above, they've given us the values for those ones. So this is equal to 0.3010 plus 0.4771. And so therefore, this one is equal to 0.7781. So what do you think is going to happen on B? How am I going to get 1.5? Well, this is equal to log base 10 of 3 over 2, isn't it? And if I have a quotient, then what I need to do is to subtract the 2. So it's log base 10 of 3, and it's always the numerator first, minus log base 10 of 2. Okay, so log base 10 of 3, well, that is 0.4771 minus 0.3010. So what do you get when you subtract those ones? 0.1761. Now they're the two really easy ones. After that, things get a little bit more complicated, not too complicated though. Log base 10 to the power of 9. So how can I get 9 out of 2 or 3? Well, log base 10 of 9 is the same as log base 10 of 3 squared. Okay, but we know from our log law that that is equal to 2 log base 10 of 3. Well, that equals 2 times, what did we say 3 was? 0.4771. So what is that going to be equal to? So 0.9542. I'm hoping. I'm doing that off the top of my head. I want to see if you can work out the last one. So you've got to start thinking here. This one's going to have a couple of steps. How can I get 12 out of 2 and 3? Remembering that we can multiply them, we can divide them, and we can raise them to a power. Okay, we'll check the answers when we come back on Wednesday. Good luck, and I'll see you in class.